All right, so we've done some everyday conversions, whether we're talking about cooking, for example, going from gallons of something to cups, or being able to go from units of volume to mass. We did a little practice with that, but this is really going to hone in on that skill of unit conversion. And so what you'll notice here, this is a table that you will always be given. These list all of the prefixes. So before I talk about what a prefix is, I'm going to really quickly talk about what a base unit is. So a base unit are those everyday units that we use to measure different values. So if I'm talking about measuring length, my base unit would be meters. If I'm talking about measuring time, it would be seconds. That would be my unit, my base unit. If I'm talking about measuring volume, my base unit would be liters. And if I'm talking about measuring mass, my base unit would be grams. Now that's great, but what if I have 1,000,000 grams, right? The mass of something is 1,000,000 grams. Well, having to write out 1,000,000 grams would be kind of inconvenient. Wouldn't it be better if I had a unit that was better able to represent that large quantity? And that's where prefixes come in. We've experienced, and you should be familiar with some of these prefixes because we use them in everyday life. So for example, when we're talking about mass, especially in Europe, they'll talk about the kilogram. So kilo is the prefix, gram is the base unit. So you can talk about the mass of something being in kilograms, or you can talk about a kilometer. Kilo, again, is the prefix, meter is the base unit. So a kilometer is a measure of distance. We also talk about, for example, centimeters. So centi is the prefix, and the base unit in this case is meter. So centimeter. So if you notice, all of these prefixes up above here, right? Tera, giga, mega, kilo, hecto, and deca. All of those prefixes make the unit larger. So you'll notice if I use the unit meter, 1 terameter, so my base unit here is meter, so I'm going to write this up here, 1 terameter equals 10 to the 12th meters. So my base unit I'm using is meters in this case. I can do the same thing with seconds. 1 terasecond, so I could change this to seconds. 1 terasecond is 10 to the 12th seconds. So this prefix has made the unit larger. It's 10 to the 12th seconds. Okay, let's look at a couple more quick examples using this. So let's look at hecto. I'm going to use a base unit of grams now. So 1 hectogram equals 10 to the second grams. So this is a relationship that we're going to be using when we're converting. So all of the prefixes above this base unit section, those prefixes all make the unit larger in value. In contrast, when we go below, all of these prefixes actually make the unit smaller. So for example, I'll use one that we're familiar with, centimeters, right? So my base unit here is going to be the meter. So 1 centimeter equals 10 to the negative second meters, right? Or 1/100th of a meter. So by putting centi in front of meter, you're actually making that unit smaller. So if I'm measuring the length of my calculator, for example, I'll probably want to be in centimeters versus in meters, because that would give me a very, very small value if I'm measuring the length of a calculator in meters. It would be like saying 0.2 meters is the length of my calculator versus saying 20 centimeters is the length of my calculator, for example. All right. Notice a couple of things just to help keep everything straight. All of these relationships, notice the way that this is written, and this is what will be given to you. You'll be able to use this as a resource whenever. A 1 always goes in front of the unit that has the prefix. So 1 deci, for example, second, we can say 1 decisecond equals 10 to the negative first seconds. So no matter what, whether it's a gigameter or a decimeter, the 1 goes in front of the prefix. And then the relationship goes in front of the base unit, whether it's meters, seconds, liters, or grams. All right, so I'm going to be referencing this back as we look at some conversions right now. All right, so here are the steps. We've looked at this a little bit. You kind of do the math automatically in your head, but this is going to be a requirement that you actually show this work. So I'm going to walk you through a bunch of examples just to make sure it's clear. So our first step in unit conversion is to write our given. So for example 1, it says how many meters, so I'm wanting you to convert into meters, are in 14.2 decameters. So decameters is my given. So I'm going to start with 14.2 decameters is my given. All right, and my step 2 is to crisscross swoosh. And by that, I just mean crisscross swoosh. Now, I'm going to write the unit that needs to be canceled out in the denominator. So I'm in decameters right now. I want to get out of decameters. So I'm going to put that on bottom, because when you put it on bottom, the decameters that you're in with your given for 14.2 decameters, that will cancel out with the decameters that you put on bottom. Then you're going to write the unit you want to convert into in the numerator. So I want to get into meters. So notice, just unit-wise, since decameters is on top, those would cancel and you're left with meters. All right, that's why I wrote it that way. Now, we have to write the conversion factor, right? So what is the relationship between meters and decameters? So I'm going to go back to my table. I find deca, and it says 1 deca base unit equals 10 base units. So remember, your base units can be meters, they can be seconds, they can be liters, they can be grams. In this case, it's meters. So the relationship or the conversion factor I'm using is that 1 decameter equals 10 meters. So I'm now going to plug that in. I'm going to remember 1 decameter is 10 meters, and I'm going to plug that in. So in front of the deca is 1, because 1 decameter equals 10 meters. And the reason why I put those units, or those values where I did, is because that is the relationship that's given to me. I always put the 1 in front of decameters, the 10 in front of meters. So now I just need to do my math. So I have 14.2 times, well, the 10 is in the numerator, so I'm going to multiply by 10. If the 10 had been in the denominator, then when it's in the denominator, you divide. But in this case, it's not. It's in the numerator, so I'm going to take 14.2 and in my calculator, multiply that by 10, and I get for an answer 142, and my units are meters. A couple of things I want to check. First, I want to make sure I have the correct number of significant figures. 14.2, my decimal is present, so I'm counting from left to right. I have 1, 2, 3 significant figures, and I have 1, 2, 3 significant figures here. Actually, I should have counted from right to left. So I have 1, 2, 3 sig figs. That's step 1. Step 2, are my units correct? Yes, I wanted to convert into meters. I put my units of meters there. Now, if you want to write instead of 142, let's say you plug this into your calculator and it gave you 1.42 times 10 to the second meters, that is perfectly fine. 142 is in standard notation. 1.42 times 10 to the second is in scientific notation. So either one is totally fine. Let's look at another one. So remember, I'm going to start by writing my given. My given is 4.5 times 10 to the negative 8 grams. So I'm going to write my given. I'm going to then crisscross swoosh. I'm going to put the unit I'm trying to get out of on bottom. So I'm in grams, so I want to get out of grams, and I want to get into picograms, PG. I'm going to go back to my table, and I see that 1 pico base unit is 10 to the negative 12 base units. So what exactly does that mean for this problem? My base unit for this problem is going to be grams. So 1 picogram equals 10 to the negative 12 grams. So I'm going to remember that relationship. 1 goes in front of pico, 10 to the negative 12 goes in front of grams. So I'm going to put a 1 in front of my picograms and 10 to the negative 12 in front of grams. So in my calculator now, I'm going to take 4.5 times 10 to the negative 8th, and I am going to now divide by 10 to the negative 12th because the 10 to the negative 12th is in the denominator. So that gives me for my answer, when you plug it into your calculator, 4.5 times 10 to the 4th, and my units are picograms. All right, looking at these two problems, both of these answers make sense. I have 14.2 decameters to begin with. That's a very big unit. So when I convert it to meters, which is a smaller unit, my number gets bigger. That makes sense. For this one, I'm going from grams into picograms. Picogram is this much smaller unit. There are 10 to the negative 12 grams equals 1 picogram, or 10 to the 12 picograms equals 1 gram. So picogram is very, very small. So it makes sense that instead of being 10 to the negative 8th, now it's 10 to the 4th, right? There are way more picograms per gram. Quickly, I'm going to double check my sig figs. I have 2 significant figures for 4.5, 1, 2. 2 sig figs here, and I included units, so I'm good to go. All right, let's look at the next one. Convert 34 milliseconds, so seconds are my base unit now. So my given is 45 milliseconds, and I'm gonna get into seconds. So crisscross swish. I wanna get out of milliseconds, so I'm gonna put that on the bottom, and I'm gonna get into seconds by putting it on the top. And again, I'm gonna go back to my table. I'm looking at the prefix milli now, so I go down here. And now my base unit, instead of being meters or grams, now my base unit is seconds. So 1 millisecond equals 10 to the negative 3rd seconds. So I'm going to remember that, 1 in front of millisecond and 10 to the negative 3rd in front of seconds. And I'm going to plug that in. So 1 millisecond is 10 to the negative 3rd seconds. So I'm going to plug that into my calculator. 34, I'm going to multiply by 10 to the negative 3rd. And so you might end up with 2 different answers. You might end up with 3.4 times 10 to the negative second. That might be one answer you get. Just double checking myself on that, yeah. And my units are seconds. Or you could end up with 0.034 seconds. All right? 3.4 times 10 to the negative second seconds. That is in scientific notation, totally fine. 0.034 seconds, standard notation, totally fine. Both of those have 2 sig figs, which is what my original given has, and I included units. So I'm good. Let's try another one. Convert 3.5 times 10 to the negative 9th microliters. All right, we got a new base unit here. Times 10 to the negative 9th micro. It's very tiny. And I got to crisscross swish and get into liters. So I want to get out of microliters, so put microliters on the bottom and put liters up top. Go back to our table. Micro is here. So my base unit again is liters now. Right? So it's liters, not grams or seconds or meters. So 1 microliter equals 10 to the negative 6 liters. So 1's going to go in front of microliters, and 10 to the negative 6 is going to go in front of liters. Okay, so 1 microliter is 10 to the negative 6 liters. 3.5 times 10 to the negative 9th. I'm going to multiply by 10 to the negative 6 because it's on the top. If it were on the bottom, I would divide. So I have 3.5 times 10 to the negative 15th liters. Now, this is a very small number. If you had written point, had 14 zeros in front and then 3 5, technically that's correct. That's in standard notation. But please, if you have a ton of zeros because you have a really small number, please put it into scientific notation. I've got 2 sig figs for both answers, and I included my units. All right, so here is the question. What if, instead of giving you a unit that has a prefix and you getting into the base unit, or vice versa, what if I give you 2 units that both have prefixes? I don't know, I mean I do, but I haven't given you the relationship between kilograms and milligrams. I gave you the relationship so that you can convert from kilograms into grams. You know how to do that. So when I give you 2 different prefixes, instead of it being a 1-step problem, this is actually going to be a 2-step problem. I know how to go from kilograms to grams, and I'll show that in a moment. And I know how to go from grams to milligrams. So this is going to be a 2-step problem for me to complete this. Again, I'm going to write my given just as before, 863 kilograms. But now, instead of directly getting into what I want to get into from my given, I first have to get into the base unit. And the base unit in this case is grams. So I'm in kilograms. I want to get out of kilograms, so I'm going to put it on the bottom. And I'm first going to get into grams. I'll have a lot of students who will write this out. They'll get into grams, and then they'll start a whole nother problem to go into milligrams, but I don't see the point. Just keep going. You got rid of kilograms. You're in grams now. Let's now go get out of grams and get into milligrams. All right, so now we're going to use this. And we're going to look up the relationship between grams and kilograms, and then milligrams and grams. So let's go back. So the relationship between kilograms and grams. So my base unit is gram. So 1 kilogram equals 10 to the third grams. All right, so I'm going to plug that relationship in first. I know that 1 kilogram is 10 to the third grams. Awesome. And then I'm going to look at milli. So I'm going to go back, I'm going to scroll down. Instead of millisecond now, oops, I'm now in milligrams. I changed base unit, but again, same thing. 1 milligram is 10 to the negative third grams. So 1 in front of milli and 10 to the negative third in front of grams. So now I took a problem that seemed unsolvable and made it very manageable. So I'm going to take 863 and I'm going to first multiply by 10 to the third because it's in the numerator. And then I'm going to divide by 10 to the negative third because the 10 to the negative third is in the denominator. So when you do this, you end up getting 8.63 times 10 to the 8th in your calculator. And my units are milligrams. And that's it. Okay, let's try one more just to make sure we feel really good about this. So for this one, I'm in nanometers, that's my given. So 5.4 times 10 to the 7th nanometers. And again, I have 2 different units that have prefixes on them. So instead of having this be a one-step problem, I'm first going to go from nanometers. I'm going to first get into meters because I know the relationship between nanometers and meters. And then I'm going to get into kilometers. All right, so let's do it. I'm in nanometers. I want to get out of nanometers first into meters. So I'm going to put nanometers on the bottom, and I'm going to put meters up top. That's my first step. I don't want to stop there because I want to get into kilometers. So I'm going to get out of meters by putting it on the bottom and into kilometers. And now I can look at my chart and figure out the relationship. So I'm going to go back here. I look at nano, okay, oops, I gotta go back 2. So nano is right here. So 1 nano, my base unit, is meter. So 1 nanometer is 10 to the negative 9th meters. So I'm gonna plug that in. 1 nanometer is 10 to the negative 9th meters. 1 nanometer is 10 to the negative 9th meters. And then I gotta put the relationship between kilometers and meters. 1 kilo, now my base unit is not grams, my base unit is meters. So 1 kilometer is 10 to the third meters. 1 kilometer is 10 to the third meters. I'm going to plug that in as well. 1 kilometer is 10 to the third meters. Now I just have to do my math. 5.4 times 10 to the 7th. I'm going to first multiply that by 10 to the negative 9th because it's in the numerator. And then I'm going to divide that by 10 to the third. And that gives me 10 to the negative 5th. 5.4, I'm just double checking my math, times 10 to the negative 5th. And my units are kilometers. Doing a quick check because I think I forgot to do this before. 5.4 has 2 sig figs. 5.4 still 2 sig figs. I included my final units, which are kilometers, and I'm good to go.